Okay, Chapter 5 Exam Review video covering problem number 24. We're converting directly from base 2, that's binary, to base 16, that's hexadecimal. You have to use your sheet. So when you use your reference sheet, first thing we want to do with base 2 to 16 is starting from the right to the left, group in 4, groups of 4. So I have 0, 1, 0, 0 there, 0, 1, 0, 1, backwards, of course, and then just 1. When you have just one, less than 4 here, you pad the remaining values with 0. So now that I've done that, I can now look in the chart and look in the hexadecimal symbol to see what these would be worth. So look at the binary grouping column and then look for these 4 numbers and then write down the hex symbol. So for the binary grouping 0001, it would be the hex symbol 1. For the binary grouping 1010, that's the hex value of A. And for 0010, it's the hex value of 2. Remember that we changed from base 2 to base 16, so you need to write the 16 base. It's much easier to go from base 16 to base 2 because you don't have to do any of that grouping. All you do is look at the chart. For D, it is 1101. For E, it is 1110. For A, it is 1010. And for F, it is 1111. Don't forget we converted from base 16 to base 2. Problem number 26. We're trying to find the sum product quotient or difference here and give the answers in both standard form, again that's Arabic R numbers, and the original base. Now with base 2, if it's a number that falls between 0 and 15 that's on the chart, you don't have to go through the long method to convert it. You can just look at the chart. And I've done the long method on the actual paper pencil key, but here I'll show you how you can just use the shortcut that we just did. Well, this is a 4-digit grouping, 1011. In the binary chart, if you convert to base 10, which is what you want to do, you will get the value of 11. Plus, and now look at the binary grouping 1110 and convert to base 10, and you get the value of 14. It's an addition problem. Add them together. The first answer is 25. Remember, that only works for binary groupings or hexadecimal groupings that fall within 0 to 15. No other numbers are in that chart, so anything that doesn't fit in that you're going to have to do by hand. Okay, and now we're going to convert this number, which is our base 10 standard number, into the original base. Well, the original base was base 2. Anytime you're going from base 10 to a different base, we divide by the new base. So I'm going to divide by 2. So 2 into 25 goes 12 times. 2 times 12 is 24. Have a remainder of 1. Keep going until this bottom number is 0. 2 into 12 goes 6 times. 2 times 6 is 12. Remainder is 0. Keep going. 2 into 6 is 3. 2 times 3 is 6. Remainder 0. Keep going. 2 into 3 goes 1. 2 times 1 is 2. Remainder 1. And last time, 2 into 1 goes 0. 2 times 0 is 0. Remainder 1. When this bottom value is 0, you may stop, and the answer is this value written bottom up. So 11001. Put the new base, base 2. So here's your standard or base 10. Here's your original base, base 2. Okay, let's do another one. This time it's base 16. So I really can't use the shortcut method so much. I'm going to have to use the long method. So I multiply to convert a different base to base 10. So 7C16, when I convert it, we multiply by place value. So this first digit is 16 to the 0, and the second digit is 16 to the first. So it's digit times place value plus digit. Well, C, we can't write C, so look in your chart and you'll see that C is worth 12. So 12 times 16 to the 0. And then use your calculators. 7 times 16 to the first is 112. Remember, anything to the 0 power is 1, so 12 times 1 is 12. Add the numbers and you get 124. Now let's convert 2f base 16. Again, the place values remain the same, so 2 times 16 to the first. And again, I can't use f, so use your chart, and you see that f is the value of 15, so 15 times 16 to the 0. Do the math. 2 times 16 to the first is 32. 15 times 16 to the 0 is 15. Add the numbers, and you get 47. Alright, now we've converted the two numbers. Well, what do we want to do with it? You see it's a multiplication problem. So what you want to do is multiply these two numbers together, and when you do, you get the number 5,828. That is base 10 or standard form, and now we want to convert back to the original base. Well, the original base was base 16, so we're going to divide by 16. So 16 into 5828 goes 364 times. 16 times 364 is 5,824 with a remainder of 4. Keep going. 16 into 364 goes 22 times. 16 times 22 is 352 with a remainder of 12. Keep going. 16 into 22 goes 1 time. 1 times 16 is 16 with a remainder of 6. And last time, 16 into 1 goes 0. 16 times 0 is 0, remainder 1. We cannot use two digits to represent one place value, so on your chart, if you recall, 12 in hexadecimal, base 16, is the value C. Write your answer bottom up, 16C4, base 16. Okay, one more problem in Chapter 5's review. Convert 4 to base 5. Same way, 4 times 5 to the first plus 2 times 5 to the 0. That's going to give you 20 plus 2 is 22. Convert 3, 3, 3, 3 base 5. 3 times 5 to the third plus 3 times 5 to the second plus 3 times 5 to the first plus 3 times 5 to the 0. Okay, when you do all that math, you get 375 plus 75 plus 15 plus 3, and that adds to 468. Well, this time we're dividing, so 22 into 468. Now, division's the hardest because you could have a remainder, and we do here. 22 goes into 468 21 times, and when you do that subtraction, you see that you have a remainder of 6. So one answer is 21, remainder 6. That is the standard form answer, or base 10. Now we want to convert that back to the original base, and the original base here is base 5. So we not only convert the 21, but you also convert the remainder. So you have two things to convert. So 5 into 21 goes 4 times. 5 times 4 is 20, remainder 1. 5 into 4 goes 0 times. 5 times 0 is 0, remainder 4. So that first one is 4, 1, base 5. Now let's convert the remainder. 5 into 6 goes 1 time. 1 times 5 is 5, remainder 1. And last time, 5 into 1 goes 0. 5 times 0 is 0, remainder 1. So the remainder of 6 converted to 1, 1, base 5. So the difference with division is that you might have to convert a remainder as well. That completes Chapter 5's exam review.